There's a literal epidemic of myopia. This is short-sightedness. Cases have pretty much doubled over the last couple of decades, and studies have shown that the main cause for this is an increase in near work and less time spent outdoors. If, like me, you spend most of your working day looking at a computer screen indoors, that's pretty worrying. If you're new here, this channel documents my experiments as I try and work out what the ultimate way of doing various day-to-day tasks is through interesting workflows and good product design. I'm a software developer and I work on a product called SetSeed CMS, which means I'm working looking at a computer screen day in, day out. So this is an area that's really important to me. I want to make sure I'm not damaging my eyes working on a computer. When I got my prescription for these glasses, it was mostly due to an astigmatism in one eye, but there's also a very mild myopia prescription on there as well. So I decided at that point to make sure that I was doing everything I could in my home working setup to minimize the chances of this myopia getting worse. And it's been years now and I haven't had to change my prescription, and I do feel what I've done here has made sure that working with computers in this way isn't contributing to my myopia any further. So what's really shocking about myopia is it's so much more serious than I initially thought. Originally, I was kind of thinking, okay, so you might end up with glasses to be able to see into the distance. That's not the end of the world. But actually, having myopia increases the risks of other illnesses, including getting a detached retina. And the reason for that is that the cause of myopia is your eyeball actually stretches front to back, elongates, which puts tension on the retina. And that's what can lead to it actually detaching, which is just a horrible thing and really a serious problem that can lead to permanent blindness. And it also increases your chances of getting cataracts and glaucoma as well. Of course, I'm not a doctor and none of this is medical advice, but if you want to see what a real eye doctor has to say about myopia and the increased risks of other really serious illnesses, you should definitely watch this video. I'll link to it in the description. It's really alarming stuff. So this is a really serious risk. Now, obviously, a lot of the attention with kind of near work is drawn to people using mobile phones. And obviously with kids, that's clearly the main problem. But if you're using a computer screen all day as well, that's still near work and it's contributing to this problem. So there are these two major components that are associated with the rise in myopia cases. One of them is spending less time outdoors and the other is spending more time doing near work. So that's reading or looking at screens or anything where you're focused close. And if you look at how that mechanism actually contributes to it, what actually happens is because your eyes are holding tension in the ciliary muscles to focus at that close distance, your eyeball then ends up changing its shape. It ends up elongating. Now, obviously, when you're outdoors, you're naturally looking further away all the time. So the focus issue kind of applies to both of these. But the studies do also show that it's actually the brightness and the light frequency and intensity associated with being outdoors that causes dopamine to be released and your eye then grows in a more healthy way as well. So it's not just about the focus, but if we're working on computer screens, that's one of the things that we can control. So when your eye is focusing up close, it's called accommodation, and the ciliary muscles in your eye are under tension to make that possible. What's interesting is there is actually a distance where those ciliary muscles are in a relaxed state, and this is called the resting point of accommodation. And this seems to vary a little bit by study, and it's also said to get further away as you get older, but it seems to start at around 70 centimeters. And it seems like this definition of near work basically means up to that kind of distance. So as far as the resting point of accommodation is concerned, it stands to reason that the nearest your screen should be is 70 centimeters. But there's actually more to it than this, because there isn't just the resting point of accommodation, there's also a resting point of vergence, which is where the muscles that control the convergence of your eyes as you look at an object closer are actually at a state of being relaxed as well. And that is actually a bit further away than the resting point of accommodation. And when you look at studies that identify what causes eye strain when you're looking at a computer, it seems to be the resting point of vergence that is actually a primary factor. So if we want to avoid eye strain, which is clearly a big part of being productive when we're working with computers, we need to be thinking about the resting point of vergence as well as the resting point of accommodation. And because the resting point of vergence is further away than the resting point of accommodation, that's then the minimum distance that we want to be thinking about for our screen. And that's said to be about 110 centimeters. But what's interesting about all of this is there's no reported penalty for being even further away than that. So the solution I've come up with here is to use this 55-inch OLED 4K television as my computer screen. So when I bought this 55-inch TV screen to use as a computer display, I actually had ideas that I was going to use it for films at the weekends, and that was kind of partly what led me to getting the 55-inch screen. But it actually works out really well at about 120 centimeters or 130 centimeters away. It's pretty much perfect in terms of field of view as a normal computer display. And it's actually obvious after a day looking at this thing, my eyes don't feel tired in the same way they do than if I was using a nearer screen on an iPad, for example. So what's interesting about this size at that distance is it's pretty much equivalent to a normal computer size at a normal viewing distance. Obviously, as you move it back, it has to get bigger to maintain the equivalent field of view. And that's not only about the size of the screen, of course, it's about the size that the text is rendered in your interface. Now, what's interesting about using a 4K screen is it has enough pixels for your computer to use its high resolution, its retina rendering of that text, which is where you have extra pixels that make up a normal user interface pixel, so that text can be rendered super sharp, but the overall space occupied by your interface hasn't actually changed. Now, there is another interesting consideration. This is an OLED 4K TV. Now, most of the OLED TVs are made by LG, even if they're sold under other brands, and they use a WRGB subpixel arrangement. And that means for every pixel, it's made up of 4 subpixels, and one of those is just pure white. Now, the implication of that is when you are rendering graphics from a computer screen, that's obviously quite a different use case for displaying moving video. And what can happen is you do get a weird fringing in between 2 colors. So sometimes if you've got, for example, a yellow square with a vertical straight edge and a white background, you can kind of see a fringe on the edge of that yellow square. And when I first got this screen, that was actually quite apparent and I found it quite annoying, but I don't actually see it at all anymore. I've completely got used to that. So it is something that you can live with. And generally now I'm just left with the benefit of an OLED screen, which is incredible screen uniformity. That's the absolute brilliant thing about this and why it works so well as a computer screen. Interestingly, I have tried another 55-inch screen here before by Sony, and that was a VA type panel. And when you're viewing a screen this size at this distance, the angle that you're looking at the edges of the screen is actually really quite far off axis, and it's far enough to see a big color shift when you're using a VA panel. So I would definitely recommend using an OLED panel in this setup. The other interesting thing about that is this distance is actually pretty much bang on for the point at which you can see all of the detail from all of the pixels without actually seeing the pixels. So it's the optimum viewing distance for this kind of resolution. But if you're using a VA panel at this distance, that's enough to get the color shift off axis towards the edges of the screen. So I was kind of really disappointed in the performance of the VA panel there. If you're using it at the right distance to see all of the detail from the pixels, you get this horrendous color shift. Now, the other thing to consider with an OLED screen when you're using it for a computer display that has large areas of the screen that don't change is burn-in. Obviously, OLEDs are known for this potential to have burn-in, but the reality is in this office, I'm only using it in the SDR mode. I'm not using it in the HDR super bright mode. The screen OLED brightness is actually usually about 10 or lower. So I don't think there's really any risk of burn-in. You know, I am a bit sensible with it. I have the Mac menu bar set to hide, so I'm not getting the Apple always at the top left of the screen, for example. I've had this screen for at least 5 years now, and I haven't actually seen any evidence of any burn-in at all. One of the other things I do in this office to make sure I'm comfortable while I'm working all day on a computer is to use a Dyson purifying fan. And interestingly, there are some alarming health risks associated with using just a normal fan instead of a purifying fan. And I go into that in this video, so watch that next and I'll see you there.